Hello, geometry teacher for Mr. Fry. Today is February 22nd. This is due February 25th. I want to take you through some of the problems, at least, you should have from class, the top filled out. If you don't, maybe look into it or at least get the problems done, and maybe while we're talking about these problems, you'll get some of the other ideas that need to be up there. I'm not sure. I was in a webinar today, so I didn't get those extra notes, but I do have the problems here for you. I wanted to get something out to you guys. So let's see here. Each quadrilateral below is a rectangle. Find the missing measures. So here we go. So because it's a rectangle, we know that these are 90-degree angles. We know that the opposites are going to be congruent, and we know that that these diagonals are bisecting each other, so they're going to be all equal in their lengths also. So QR should be the same as PS 10, SR should be 24, SQ, this is going to be 26. How I got that? Okay. The Pythagorean theorem, and I'm not sure if you guys talked about that in class or what method you're using, but this plus this, I have a 90-degree angle. This is going to be the hypotenuse. So 10 squared plus 24 squared is going to equal this SQ. So I add those together. I take the square root of 276, and that equals 76. So that would be the square root. Okay. And that equals 26. That's how I got 26. And then QT is going to be half of that. It's going to be 13. Number 3, MJK is 90 degrees. MJK, that's the 90. And then to find MJL, all you're going to do is take 90 minus 27. That's going to give you your 63 degrees. JLK is going to be 63 also. That means KML is 27. 27 was given to us, so we relate that to KML. And then MNL, you're just going to take 180 minus 27 again, because those two 27-degree angles, and you're going to get 126 degrees. For number 5, we're given that DB is 42, so the whole thing is 42, so that's 21 and 21. AD is 26, the side is 26. And DAE is 52 degrees. Okay, so I went ahead and, 90 minus 52 is going to give you 38. So this is going to be a 38, this is going to be a 38. This is going to be a 52, this is going to be a 52, this is going to be 38, this is going to be a 38. Okay, remember these are going to be, 180 whatever minus 38, 180 minus 52 minus 52. And in order to find the other side, this side, it ends up being, and I don't like it, they could have chose numbers that would be square root. It's pretty much 33, so it's pretty darn close to 33. It's 32.9. Okay, so with all that information, these should be your answers related to all the information that we were given. How I got that 33, once again, is the Pythagorean theorem. And here you have it listed here. This is a B, not a 6. That would be side B in the Pythagorean theorem, which is A squared plus B squared equals C squared. And I just so happen to need that B side. So this would be my A, B, and this was my C side, which was 42. That's where the 42 squared comes from. For number 6, gets a little easier. These two are just equal to each other, and you solve for x. This one, these two are going to be equal to each other, and you solve for x. But then you add them together to get the whole JL. That's just going to give you half of the diagonal. So you have to, multiply by 2 or add 10 plus 10. These two end up equal to each other because they're opposite interior angles. If we were just looking at these two and this transversal, this is why we did this at the beginning of the year. These are alternating interior angles, and they're going to be equal to each other. So you could solve for x. Once I solved for x, I plugged it in to get one of those. The other one, the BCE, is going to be complementary to that. So we just take 90 minus the 19, and we got 71 degrees. That's a little degrees sign there. For number 12, these two are you're going to be able to add these up. They're complementary. They're going to equal 90 because this angle equals this angle. So adding these up would give you 90. So adding these up would give you 90. Okay? See my reasoning behind that? Combine your like terms, isolate the variable, and once you take that information, put it in this one because this one's going to equal xzy. xzy, or xzw, I'm sorry, xzw. They're asking about xzw. So it's going to equal this one. This one is going to be equal to this one. So that's why I plugged it into this one once I found my x value. And I got 57. So that'd be 57 degrees. Put a little degrees sign on there. Moving into more problems that were part of these notes, we're working with rhombi, rhombus, the plural of rhombus. Notice in all of these interior angles are all going to be 90, so that's going to help us find some other angles. But in the meantime, since we have a 90-degree angle, we also have A plus B equals C. We have that whole Pythagorean theorem thing going on there, and I used it to find MK. And then I multiplied it by 2 because I found NK. And so multiply by 2 because this is going to be double that. So it would be 19.5. You can see my other measures here as they relate to the information that was given me. For number 3, VT. VT ends up being 11. It's just RT in half. UV ends up being 9, which is just US in half. RS ends up being 14.2. And ST ends up being 14.2 also because remember in a rhombus, all the sides, it's a square, but just the angles aren't congruent. I mean, the angles are, not all 4 angles are congruent, I should say. Okay, but all 4 sides are still the same. And I found that 14.2, once again, by using the Pythagorean theorem. This would be 90-degree angle. So I'd have 9 squared plus 11 squared, or 11 squared plus 9 squared, equals C squared, and I end up square rooting 202, and I got 14.2-ish. Number 5, you can see all the information that I put in there with the information that was given. You can see how I found ZV. Had to use the Pythagorean theorem. Once again, that's a B there. Pythagorean theorem, once again, A squared plus B squared equals C squared, okay? And I was given an A, and I needed to find, and I given a C, but I was needing to find one of the legs of the hypotenuse, or of the 90-degree angle, and that was that B that I needed, and it ended up being, 28.2. Here are all the other points that we need, or all the other degrees and lengths of sides, given the information that we took into consideration. Number 7, looking at a square here. Once again, you could use the Pythagorean theorem. I had to use it to find PQ. we just know that this is 17, so that means all of these are 17 in here. And knowing that, well, 17 plus 17 is 34, so the whole thing, this whole diagonal PR would be 34. Same with QS. QT would be half of 34, which is the 17. PQ, now to find this, I know the legs, this is a 90-degree angle, so I have a squared plus b squared equals c squared, right? It ends up being close to 24, 24.04. The measures, the angles of the measures, you know that these are 90 degrees, so if it's bisecting it, you got 45 and 45, so you have 45s and 90s. Take a look at number 9. These two are going to equal each other. Because this one plus this 90, you know, that's how that's going to go. But these two are going to equal each other actually. So I just set them equal to each other. I got 7 equals x. I plugged the 7 back in. And then in order to find FED, I had to take that 90 minus that amount to get 54. And FED is both of these together. So if this one's 54, that means this one's 54. So the ones that are adjacent, ones that are next to each other, are going to be equal to each other. So these two angles are 36. These two angles are 54. So 54 plus 54 is 108. So this is, you can see it's obtuse. It's more than 90. So it makes sense, 108. And then number 11, solve for x. Well, that's going to equal 45, if that's a square, because the diagonal bisects it equally into 2 equal parts. So your x is going to equal 6. Try the even ones on your own. Go ahead and make mistakes, learn from them. That's how we move forward.